Live. Today we're honored to have with us Dr. Dale Klein, a distinguished faculty from the University of Texas at Austin, whose contributions to the field of nuclear engineering have not only been pivotal to academic circles, but have a profound impact across the United States and across the world. Dr. Klein, thank you for joining us today.
Thank you. It's a pleasure, and it's good to have ANS being active.
So we'd like to open with a spark of passion. Dr. Klein, to start us off, could you share with us what initially drew you to nuclear engineering?
Well, that was a great question. I grew up on a farm in Missouri, and electricity absolutely revolutionized the farm. We went from hand milking to machine milking for the cows. We went from having to shovel all the grain by hand with augers. And so electricity really revolutionized the way the farm life was that I grew up. And so I really wanted to get into the electricity business. And growing up on a farm, I'm very environmentally conscious. And so I picked the technology that I thought was most environmentally sound to make electricity, and that was nuclear. So that was how it happened.
And how did you discover nuclear? Was there a pivotal moment?
I think when I was finishing my undergraduate degree, I had a couple of nuclear classes, and that really got me excited about the opportunity of how we could use the atom to create electricity. And that really was what sparked my interest. And when you look at the compactness of splitting an atom versus burning something, it is a very energy efficient way to generate electricity.
And so reflecting on the early days of your career, what are some foundational experiences that shaped your journey? Were there particular challenges that you felt were instrumental to defining your approach to your work?
Well, I think the first inspirational part was the mentors I had as an undergraduate. Growing up on a farm, there were very few of us that went to college. And so when I went to college, I thought the whole world lived in Columbia, Missouri. I'd never seen so many people in all my life. So I think my pivotal moment was the mentors I had in engineering as an undergraduate. And then as I came to completing my PhD, I was going to work in industry. I'd worked in industry before for Procter & Gamble Company as a design engineer. And when I went back and finished my PhD, my department chairman kept nudging me into the academic world. And I kept saying, no, I want to go out and get a real job. I don't want to go into academia. But I came down to UT for the interview, and that interview really changed my mind and it changed my career. So it's been an exciting career and really a dynamic one.
And how were your early days at UT Austin?
I think the early days of any assistant professor is demanding. You put in long hours, you have to develop your lectures, and what surprised me was it took me about 3 hours of preparation for a 1-hour lecture. And so I underestimated the amount of preparation time it would take to teach. And then you also have to write research proposal to support your graduate students. So that was a very important part of a faculty member, is be able to get research funding to support your graduate students.
Could you walk us through your career, because you've been all over the United States and been in many influential roles. How did the role as assistant professor at UT to tenured and then moving forward? Could you outline your career for us?
I always tell my students that a lot of my career was based on luck, but I did learn the harder I worked, the luckier I got. So there's a motivation there for people to work hard, and when you work hard and you do good work, naturally things happen. So for example, when I first came, I became the director of our nuclear program about a year after I was hired as an assistant professor. That was because the previous director left for private industry. So that was just an opportunity. It just sort of fell in my lap. And then as I progressed through the tenure track, the Dean of Engineering at the time asked me to be his Associate Dean for Research. So a lot of those just developed. They were not planned, they just happened. And you have to take advantage of those opportunities that present themselves. The same thing that happened when Governor Bush was elected president. He asked me to come to Washington, D.C. and work at the Pentagon. So all of those things just sort of happen, and you just have to be ready to take those opportunities as they come.
Before we move into past UT, you oversaw lots of changes during your tenure at UT the first time around. What were the most exciting changes you saw, and what were the most challenging aspects there?
I think one of the most exciting was when we had the chance to build a new research reactor at the Pickle campus. So when I came and was director of our research reactor in the old Taylor Hall, it was one of the very early reactors that came in. It did not have the capabilities that the new research reactors had. And so the provost called me up one morning. I was in my office early, as always. So 7 o'clock, the phone rings. Provost says, "Come up to my office." I said, "Yes, sir, I'll be right there." So I came up, and he said, "We're going to shut down the reactor in Taylor Hall. Do you want another one or not?" and so basically then that involved to designing the new research reactor that gave our students and our faculty a lot more research capabilities. So that was one of the most exciting things, I think, early in my career that started. But I think UT has been a great place to start. I think the students are great, faculty are great, and it's a dynamic institution.
And how was your transition to the Pentagon when that, how did that phone call go?
Well, what was interesting, when I learned later, a presidential appointee, Senate confirmed, is a challenging opportunity. You can become a target just because you're there. It doesn't mean that you're good or bad. You end up being a target. So I know colleagues that were held up 2 years trying to get through the confirmation process. I was rather lucky in my case. I knew in April of 2001 that I was likely to go, subject to confirmation. You always have to say that. So I knew I was likely to go up in the Pentagon. And then 9/11 occurred. And then after that, things went on a warp speed. So I went through a very fast confirmation because they wanted to fill the nuclear, chemical, and biological defense program because we knew the terrorists were after us. We just didn't know their capabilities. So that went fairly fast. And then I was ready to come back to the University of Texas, and President Bush heard I was coming back. And so then he asked me to be the chairman of the Nuclear Regulatory Commission. So all of these things they sort of evolved. But again, I think for the student's perspective, if you work hard and you're lucky, good things happen.
Your work has often been at the intersection of innovation, policy, and real-world applications. Can you discuss a project or initiative that you're particularly proud of and the impact it had?
Well, one of the things that's interesting, as an undergraduate, when I went through school, in those days, they would tell you, look to your left, look to your right, only one of you is going to graduate. So basically, we were giving the expectations of failure in those days. Now we tell our students, look to your left, look to your right, all of you can graduate. You have the capability, and if you don't, it's either because engineering was not for you or you had a different opportunities that come up. So I think the important thing for teaching is that all students have the ability to succeed, and we just have to figure out the right pathway. I think the project that was the most interesting for me was the Biodefense Initiative at the Pentagon. When I went through my undergraduate, I was taught if you get the right answer, you're finished. Now I learned that if you get the right answer, you're a third of the way there. The next third is you have to tell everyone else, convince them that that's the right answer. And then the next thing, you have to get the money to make it happen. So at the Pentagon, we were dealing with the biodefense issues. We didn't know what the terrorist capabilities were. We knew their intent was to kill us and not differentiate between in a uniform and out. But we didn't know the capabilities. And so I was able to get a $1 billion 5-year program to defend against engineered pathogens. And that was probably the most exciting program that I was able to get through the bureaucracy of government funding. But it really had an impact on protecting the U.S. citizens and our allies.
Yeah. Wow. And innovation comes with its sets of challenges, especially in the fields that affect public policy and environmental concerns. How do you navigate those challenges? What were the principles that guided your decision-making process?
Well, one of the things that I think always guided me is foundational engineering and science. In other words, I tend to be a techie. And so I would oftentimes have some lively discussions with the policy people in the Pentagon. Their view is you could solve everything with 50 gallons of ink and tons of paper. Being a technical person, I believe that science and engineering are the solutions. And so that's where policy and science sometimes collide, because people want an answer immediately and we don't have that capability. So policy is a very important part, and I think our engineering students are better able to adapt to policy than policy people adapt to engineering.
Looking at the broader scope of your field, what are some of the emerging trends or technologies that excite you the most? And how do you see them shaping the future?
Well, obviously, as I indicated earlier, electricity is very important to me. And if we're going to lift people out of poverty, we're going to do it with electricity. That's how we really better all of our lives, is through electricity. So electricity is really an important part. And I think small modular reactors have the potential to change how we generate and receive our electricity. The frustrating part for me is that most people have no idea of how we get electricity. And so I remember years ago, the Nuclear Energy Institute did a survey, and they asked people, where do we get our electricity? And the most predominant answer, surprisingly, was from the wall. And so basically people think electricity comes out of the wall socket. And so they have no idea of what does it take to generate electricity. So in our country, in the US, we have a very reliable, affordable, and reliable source of electricity. Other countries don't have that. I've been to India several times. I've never been to India where the electricity at some point in the day didn't drop off. And so in the US, we have a very reliable source of electricity, and people just don't realize what it takes to get it there. And I think that's where we need to educate the public a lot more.
What would you see as the key ways to reach the public for this education effort?
Everybody has to be involved. You know, universities have to be involved, government has to be involved, and the private sector has to be involved. And more importantly, the media. You know, the media really has a responsibility, I think, to educate people on what the options are. Unfortunately, on the media, it is a business. And so oftentimes business drives what they cover and how they cover it. But from an educator standpoint, the media can play a big role. And I think social media will change the way we get our information, and hopefully that will help us understand nuclear a lot better.
What do you think is one of the most common misconceptions of nuclear energy?
I think probably nuclear waste. People believe that there is not a solution to the nuclear waste issue, and there absolutely is a technical solution to nuclear waste. It is a policy, political issue. It is not a science and engineering issue. It is like garbage. People want garbage picked up, but they don't want it put down, and certainly not near them. Same thing with nuclear waste. It can be handled safely, and we know how to do it. But I think the most public think of it as a green slime that's oozing out and is going to contaminate the whole world, and that is just not the case. And that's why I think nuclear is so valuable for supplying safe, reliable, affordable electricity, but yet the public has this unnecessary fear about radiation.
Have you seen public rhetoric changing more favorably with these new startups coming up?
We've seen a dynamic change in the attitude towards nuclear, and I think two things make a factor of that. One, this current generation of young people are not afraid of technology. They like technology and they embrace it. So I think you look at the baby boomers versus the young people today, there's a big difference in how they approach things. So I think the risk understanding is better with the young people today. And the other is climate change. You know, people believe that climate change is more of a threat than the perceived threats of nuclear energy. And so we've seen a dramatic shift of people's attitude towards nuclear. And if we're going to meet climate change, we cannot meet it without nuclear. It is absolutely impossible. The numbers just do not work. So I think a lot of people are understanding that, and therefore they're approaching nuclear more scientifically rather than emotional.
What is something that you're hopeful for, looking forward to the next decade?
I would really like to see us get the small modular reactors to the point that we can buy those, make those, ship them to the site, and get them supplying electricity quicker and safer.
And balancing a demanding career with personal life must be challenging. How do you manage this balance, and what advice would you offer young professionals striving to find, their own equilibrium?
Well, I think work-life balance is very important. I don't follow my own advice. I tend to work long hours because I like what I do. And so I'd always tell my students, if you get a job you like, you never have to work again. So I think from the standpoint of if you get a job you like, you're highly motivated, and you believe you're making a difference in the world, you can put a lot of hours. But you do have to get a work-life balance. And so for me personally, we now have a ranch about an hour out of Austin, and we have a vineyard. and so we're growing grapes, and so it's been a lot of fun. You know, I'm getting back to my farming roots where I'm growing grapes and making a product that the consumers hopefully will like.
I love that. Finally, Dr. Klein, what message or piece of advice would you like to leave with our audience, especially those aspiring to leave a mark in nuclear engineering?
I would say that, first of all, the glass is half full, it's not half empty. So have a positive attitude, find something that you are passionate about, and make the world a better place.
Dr. Klein, it's been a pleasure. It's an honor to have you with us today. Your insights and experiences are incredibly inspiring. I'm sure our audience will take a lot from this conversation. Thank you for your time and sharing your journey.